Yep. Yes, ready to go. Yeah, great. All right, well, thank you everyone for coming today. My name is Cameron Robson McKee. I'm happy to be here with you today. I just want to apologize preliminarily. As you can kind of tell my voice up front, I was in Charlottesville last night celebrating a victory. So typically auditorily, I don't sound great today. I'm really not going to sound good, but unless you'll bear with me. Regardless, we've got a piece of literature in front of me that we're going to go through to kind of begin our time here. I don't know our previous adventures coming into Griffith Parker, but nonetheless, this is a reduced version of the code. Actually, the individual that wrote this document is a certified ICC instructor. We wanted to focus in within areas within the code that were hampersome, troublesome for architects and design teams in the creation of open design. So this is written off of the 2015 version of the IBC. It's just basically a go-to resource guide whenever you have to deal with fire and life safety concerns within your projects. I like to mention at the very beginning, I left a few flyers out on different tables sporadically throughout here. That individual who wrote this document is going to be in Alexandria conducting a 5-hour seminar. It's worth 5 HSW credits. It's got this lunch, so if nothing else, the lunch is going to be provided, but nonetheless, it's a great seminar. We invite all architects, design teams, whoever is interested in attending, feel free to come to that. Just give me your business card or whatever. We're happy to coordinate. Love to see you there. Nonetheless, to begin, we'll start with the table of contents is where we'll begin. Just on the inside binding there. So we're looking at the table of contents section. That's kind of where we'll begin today. If we're looking at the table of contents, the red letter items are going to be the applications or opening protectives that are going to be discussed within this document. So whether that's elevator separation, vertical opening separation, area separation, those are the different areas of concern that we're going to commonly see within design teams and struggles and such. I'd like to also mention that the individual, when they were going through and trying to compile all these sections in this document, you folks, the design teams, the architects across the country, were the ones that were coming and pitching these questions like, hey, how do we have an elevator lobby code compliant, but we don't want swing doors, we don't want mag-hold doors. We need a 1-hour rating, we need a smoke rating, but we don't want mag-hold doors in the building. What do we do? So again, you folks are the ones that kind of designed this book over time, over a long duration of a long career. We'll go through actually the elevator lobby section on page 2 to kind of begin our time here. I also left 2 product catalogs. We don't need to sell too many books unless they've got a couple product catalogs, the black documents. I think I left them on the back table there. So if anyone's interested in looking at that, the full slew of rated, non-rated stuff that the manufacturer does. So we're on page 2. We're beginning here the elevator lobby and hoistway protection chapter. The sand-colored box is always going to tell you in layman's terms what we're discussing here. So what is an elevator lobby? What are we talking about here? Those fire and life safety concerns within those particular applications. And then the meat and potatoes of what we're talking about, the code requirements. So this is the code language from the IBC, copy and pasted. Right here, all the exceptions, the provisions, all of the documents, all of the literature, the stuff that you're actually going to want to know, copy and paste it within this document. We're trying to negate you having to thumb through the big blue Bible and having to go through that document as much as possible. This is kind of a one-stop shop for all of these kind of concerns. So if we're on page 2, we're looking at code requirements. Those code requirements continue on to page 3. And we'll go to page 4 now, where we'll begin the design solution section. So obviously we're going to be using our product line and trying to combat these situations, right? It just makes sense. We're looking at the bottom of page 4. We'll see one code complying elevator lobby created, actually with the accordion door, kind of a wand door equivalent. It's got a standard push paddle hardware door, retracted or programmable distance, standard stuff. Benefits there: reduced head track in a wand door, typical assembly, 9.5 as opposed to an 18-inch head track. So also, it doesn't require batteries, so there's no battery backups. The maintenance crew doesn't have to go changing batteries going in and out of the building. So a lot of benefits with that application. No floor track needed. The only thing that you're ever going to see 99.9% of the time are those red powder-coated doors that conceal the open. They had to bipart it actually to keep it wide open there, so they didn't have to stack space on one side or the other. I'd like to also mention these products that we're going to begin with today are all 3-hour rated UL10B products that also carry the smoke rating as well. I'd like to begin with that as well. So that's on page 4. Then on 5, we get a couple more case studies being talked about here. At the very top of the page, we see in elevation just your standard accordion door, except with that 307 door at the leading edge of the assembly. We've been facing AHJs all the time, especially we just saw a project here at Bethesda, and the AHJ there was telling us, hey, we don't like that push panel, wand door kind of door. It's not intuitive enough in a fire condition. We'd rather have a swing door. Just throw it in there. It's a standard swing door. It's more intuitive in a fire condition. So that's what we see here at the top of page 5, a 3070 leading edge egress door as opposed to that push panel hardware. Just to be able, it's more intuitive, a push panel. It's very simplistic in a fire condition. And beneath that, a vertical acting door actually. That entire assembly goes face the wall into the opening, and the doors themselves sit above the opening. And the benefit with that product is that the opening dictates the amount of egress doors that you can have. We're all about egress. You can have as many as 18 egress doors. We've seen that up at a casino in Cincinnati with 18 3070 egress doors, 9 in either direction going in and out of the casino. So that's on page 5. And then beneath that, lastly on 5, another accordion-style fire door, this time emphasizing a 14-inch panel as opposed to our standard 7-inch panel, trying to accommodate for different stack sizes. And then lastly on page 6, we'll go to, this begins the inquiry, discussion, and question section. I know whenever you get through a chapter like this, oh, great. I go through the stupid chapter and I have to do inquiry, discussion, and questions. Great. Nonetheless, this can be useful. It pitches it back mostly to design teams like, hey, what was I discussing? And also, what are some questions that might come up in creating an elevator lobby, for instance? It's code commentary. It can be useful in some applicable instances. That's on page 6. Now we'll go to page 37. One more chapter and then the definitions, and we'll get started with the program. So we're on page 37. This is the atrium section. Atriums are getting so much notoriety. You're starting to see them in plans all across the country, right? I know it's getting bad. I saw one in a roadside bathroom recently. People are loving seeing atriums everywhere. With that come a lot of costly provisions in the code we see. So on page 37, same color box, what is an atrium? Fire and life safety concerns with those atriums. And lastly, the code requirements. Oftentimes we're going to see at least minimum class B finishes on your walls, reduced travel distances, your deluge systems, and the most costly smoke evacuation systems. So we're trying to minimize, we're trying to alleviate a lot of those cost requirements in those atriums by implementing some different products. And you flip over to page 38, we'll see what we're talking about with those kind of instances. The bottom of 38, we see a side acting fire door. It's a massive opening. It was well over 14 feet in height. And it actually sat off that glazing. If you can kind of look at the picture on the left there at the top, that was actually non-rated glass. The steel shutter, the 3-hour rated UL10B product, but that rating is applicable to the glass as well. So it negated the use of fire-rated glass there. A lot of cost savings potential. We oftentimes see a great amount of savings in lieu of fire-rated glass in a lot of different applications, whether it be overhead coiling steel sitting off the glass panels or side acting fire doors that sit 4 inches off the glazing in that direction as well. So that's what we kind of see on page 38. And on 39, we see a different kind of product being used. It's a horizontal fire shutter. It's an overhead coiling door that's tipped on its side and then put on its stomach, and then it goes across a tabletop plane, literally parallel to the ground. It's a unique application. It's a unique assembly in the sense that it kind of goes against the test that we're going to be talking about. Typically, these shutters are going to be in the vertical position. This is in the horizontal position in the burn furnace. Carries a 2-hour UL10B rating, and so typically it carries the smoke rating, which is really, really hampersome, especially in atrium conditions. And what's so great about it is that compartmentalizes 2 floors into one. So when it deploys, it closes off that atrium, and typically we see them trying to create 2 floors in common. It goes across that tabletop plane, and by code in separate structures when it's fully deployed. A lot of cost savings potential. We had a distributors conference recently. An owner actually saved over $1 million not having to utilize a smoke evacuation system, and removed, I think, almost 5 out of the 6 requirements that you commonly see with atriums, and utilizing this horizontal fire shutter, and actually based off of an AHJ's recommendation. So it's a code-compliant product. It's a great assembly, being able to space within a lot of atriums and gaining some press around the country as well. That's on page 39, and then on page 40 we'll go one more application. I promise. On 40, we see a side coiling fire door, just an overhead unit tipped on its side. Nothing special there. Only thing special, it can turn an 18-inch radius. Only has a 4.5-inch head track. And in this particular application, at the Cosmopolitan in Vegas, it met in the middle of the male and female joint. It was 156 feet in length. So it was a massive opening. It had to contour that tight radius curve and made it a code-complying atrium condition and closing off that open space. It did not need a floor track either, despite the extreme length shown. That's on 40 and 40. 41. Inquiry, discussion, and question section we'll be discussing. And lastly, we'll go to page 92. I swear this is the last page. I promise. I promise. And get started, please. I understand. I understand. Page 92 begins the definition section, and I can only imagine. I know I don't really care too much about it, but no, I can only imagine how much little you guys care about the differences between a firewall and a fire barrier. I'm sure it keeps you up late at night. So once again, we're trying to mitigate a lot of those conflicts and trying to differentiate those on page 92 through 97 with definitions, fire ratings, opening protection, design notes, and then the applications. So once again, what's the difference between a firewall and a fire barrier? This is going to be one of where you are going to want to go. At the bottom of page 92, we see those applications. I'd like to hone in on that for just a second because that's kind of where we're going to begin today. The application is key because back in 2000, when all the legacy codes and the BOCA codes all converged into the IBC, there's a new criteria, there's a new determination based off of the opening protective that you're going to use in your walls. Before, it was like, oh, that's a 1-hour wall, 2-hour wall, that's a 3-hour wall. There was no outside designation as to which wall you can put within your projects. Now it's the application. When everything converged into the IBC in 2000, the application was a new determining factor of what opening protective you could utilize within each space. So if we're looking at page 92 with those firewalls, exceeding area allowances are one of those areas that you're going to have a firewall in between those two spaces or a horizontal exit. So those are two areas. If we look over to page 93 and skip down to the bottom there, the applications go, there's a myriad of different applications in those because your fire barrier is going to be the majority of the walls that you're going to have in your projects. So whether it's shaft enclosure, interior exit stairways, atriums, those are going to be the fire barriers that you're going to commonly see. And then we'll go to page 94, I'm sorry. And this kind of begins what we're talking about today. Fire partitions, and then 96, 95, smoke barriers, and then smoke partitions on the last page. Because that's what we're discussing today. We've been talking about 3-hour rated UL10B products, but there's not a product that we're talking about today that carries an hourly rating of greater than 20 minutes under UL10B. We're going to talk about that, what the reason is behind that. Nonetheless, whenever you guys have to deal with these kind of situations, fire and life safety specifically, this is a great one-stop shop. We used to get known for these things across D.C. Now it's the food, which is fine by our standards, nonetheless. So whenever you have to kind of deal with this, that's a great document. I encourage you to come through that whenever you have to deal with it. So with that, we'll kind of begin. Hopefully this thing will work. There we go. All right, wonderful. All right, so fire and smoke-rated curtains, this is what we're going to be discussing today. So none of this overhead steel, side-acting steel, that's not what we're going to be discussing. We're going to be talking about this fabric product. It's gaining a lot of press on the market today. We're seeing it in a lot of different applications. So we're going to be talking about what this product is and how we can kind of use it. Please follow us on social media. I can tell everyone's enjoying the food, which is fantastic, but nonetheless, someone's got to pay for it, right? I don't want it to be you guys following us on social media is the easiest part. If you don't want to follow us, please, I'll see you at the front door, Venmo, PayPal, check, cash, money, credit card, whatever. Just let me know. That'd be fantastic. I'd be happy to see you, and I won't be forgetting. I'll be expecting that charge later, so thank you very much. Registered AI provider, I think we're signing in, so that's okay. And then lastly, it's a copyrighted presentation. Learning objectives are pointless, but we have to throw them up there anyway. So we're talking about this flexible fabric fire protective curtain product. And through that, we're going to talk about the UL standards. What's the difference between UL10B and UL10D, and why does that resonate amongst you folks? Why does that even matter? And talk about some applications, and then lastly, some different instances where you can and can't put this stuff. So what is it? What is this fire protective curtain? Something I already referenced it a few times. What are we talking about? And it's taken a number of code cycles to actually get a formal definition, as we see here. 2021 code cycle is going to be the first time you're actually going to see it in the IBC. Prior to that, the stuff came on the market in 2008, came to the United States. 2008, it came out 2009, 12, 15, 18, 21. Finally, 5 code cycles out, we have a proper definition. And this is the definition that we're going to see. The assembly consisting of fabric curtain, bottom bar, coil operating closing system. Really, really engaging stuff. Basically, it's something that you guys have specified 100,000 times. There's standard roll-up doors, right? You see them putting in a garage or some kind of insulated situation. That's what we're kind of commonly see. The only difference is that housing, right? You can kind of see all of this different nuances to this product, but the difference is that the coil box is going to be a lot smaller. We commonly see about 10 inches, less than 10 inches needed of housing for that coil box overhead, but there's a reason for that. It's this flexible fabric product, not steel, going around that barrel. And that's going to be crucial as we kind of go forward here, because that's going to determine what those applications that we were discussing as we go forward here. So pretty common stuff, motor operator, mounting and guide assembly, all of that kind of stuff. This is what we're trying to look at. This is what we're going to be seeing. So what's it made of, right? That's what we're going to be discussing. You can read this definition. I bring a copy or a piece of it from the factory with my, just so you guys get a better picture. Make sure whenever you grab it, I'm going to pass it around, grab it in the middle, not around the edges. Someone told me that the first time I got stainless steel weave in my fingers. Just grab it around the middle. But this is the exact thing that we're going to be discussing today. Gives you a better tangible, piece of what we're discussing. If you kind of bend it and play with it a little bit, it's very flexible, very flimsy stuff. And you kind of see why it doesn't receive an hourly rating greater than 20 minutes under UL 10B. But that's what we're going to be discussing. This is basically a picture if it was sitting on your face. But nonetheless, this is fiberglass coated fabric, and it's a fire retardant fabric coating. So that's kind of what we're talking about. That's what we're discussing today. And for our purposes, the only thing that matters is can it function as an opening protective? The answer is yes. Obviously, in Section 716, where everyone goes to for opening protectives, fire protective curtain assemblies are constructed of materials or assemblies or components, materials, listed, tested, whatever. Lastly, they're tested without hose stream and in accordance with UL 10D. Those are the two pieces that we're going to focus in on. UL 10D, there is no hose stream, and that's the only test that this fabric product is going to be tested under and pass. So this fabric product is tested under UL 10D, and it's without hose stream. UL 10B, there is a hose stream. They're inextricably woven together. So if you have a UL 10B test, you have the hose stream test. For UL 10D, there is no hose stream, and that's the test this fabric product gets tested under. And please stop me at any time if anyone ever has any questions in regard to anything. Be happy to explain something if it wasn't so clear. So that's in 716.4 that we see this definition for the 2021 IBC. So what is the scope of UL 10D? This is what we're going to be discussing. Back in 2017, when the IBC was pressed for an answer, once again, the stuff had been on the market since 2008. Nobody had given any proper answers of what this stuff was. This is what they came up with. This is a snippet from the document that they sent. And obviously, I want to hone in our attention to the two underlined portions. But also, there's also one portion I want to hone in on. Fire protective curtain assemblies are horizontally vertical oriented, but they also provide non-structural separation only, and they aren't intended to be substituted for hourly rated partitions or opening protectives tested for fire endurance and hose stream performance. So they're for non-structural separation and aren't to be substituted for opening protectives tested to fire endurance and hose stream performance. Those are the two things. This fabric product under UL 10D is going to only provide non-structural separation, and it's not going to be substituted for something that has been tested for fire endurance and hose stream. So what the heck is fire endurance? I keep bringing up these stupid things. Fire endurance is this age-old UL 10B test that we've talked about since day one. Back at the turn of the 20th century, there were a lot of mass casualties, especially up in the Northeast, of factory fires. They'd be building occupants from getting killed. These fires, they didn't know how to protect occupants within the buildings. So Underwriters Laboratory and National Fire Protection Association linked up. UL provided the laboratory, NFPA created the standards, and this is the test they devised, and we're still using it today to test these rolling steel fire doors. So this is the test, and it's still being used today, like I said. You roll a 12 by 13 specimen, a test specimen, so a rolling steel door, into this chamber, this test chamber. You put it in the vertical position, and you run the furnace up to 1800 degrees at least. The door, the opening protective, is going to sit there, and it's going to get burned for whatever hourly rating that the manufacturer is trying to achieve. So it's 1 hour, 2 hours, 3 hours, or 4 hours. That's what it begins with, right? If you pass that portion of the test, immediately after, you get hit with a cold water fireman's hose, 45 to 55 PSI fireman's hose. As you can kind of see, the cool air is allowed in, so there's always going to be some gimme under these rolling steel doors, and especially in this particular test. And there's a damper up at the top that allows all the hot gases, the combustion pressures, to be expelled out of the test chamber itself. So that opening protective burns there for the duration of 1, 2, 3 hours, or whatever it ends up being. If it doesn't burn the size of a quarter through the other side of the door, it passes that portion of the test, and it gets hit with that hose stream that I was referencing. This is the interactive part. Why do you guys think that they would hit a rolling steel door that's basically on fire with a hose stream? Why would they do that? Do you have any ideas? That logic would tell you that, absolutely. That's what I would think as well. I agree. Anyone else have any ideas? Thank you for answering. I appreciate it. Anyone else? Come on, I'm patient. I got a whole bottle of water right there. I got a lot of it in my hands. I got you guys for an hour. Come on. Anyone? Yes. Sprinkler. Sprinkler? It's good. What about you? Essentially, yeah, you know, those are all good answers. It's more to test the structural integrity of these products that were in there. So under UL10D, it's a non-structural test. Under UL10B, it is a structural test. And then once you put a rolling steel door within this opening, it gets burned under 1800-degree furnace for 3 hours, conceivably, it's going to expand. You apply heat to a steel product, it's going to expand. You swing it out, you hit it with a cold water fireman's hose, it's going to contract. So this is what they came up with in 1900 to be able to test that structural integrity so that the door would maintain and withstand under serious pressures. So that's UL10B. Burn portion of the test and also the hose stream. And it's to test structural integrity of the door, that hose stream component. UL10C and 10D. 10C is for swing doors, not what we're discussing. 10D is for this fabric product that we've been discussing, and this is the exact test. Anybody that studied that last diagram pretty closely can already tell the difference. It's the same furnace, same 1800 degrees, same everything, 12 by 13 specimen. It's just this fabric product being placed in that opening. Same furnace, same temperature, but that damper is actually maintained by a fire protection engineer to create this 40-inch neutral plane above the surface floor. And if you look at it, this fabric product in this opening, it creates this convex and concave nature, essentially giving it a quasi-structural integrity test. But if it passes this portion of the test, this burn portion, it passes, it carries whatever hourly rating that the fabric product was going to achieve. So 1 hour, 2 hours, 3 hours. It doesn't burn that quarter-size hole that I was discussing and through the cool side of that door. It's fine. It passes, no problem at all. And then it obtains that hourly rating. Key is, a fabric product, there's no hose stream in that UL10D test. So this is the only rating that it's ever going to achieve, is this UL10D hourly rating. Exclusively the only rating that fabric product ever is going to achieve. So what is hose stream? We've already talked about it a few times. NFPA 252 requires all opening protectives to comply with a structural integrity test, known as the hose stream, to obtain a fire rating greater than 20 minutes. There's the code language that we can kind of see down there. And then here's a great picture of the firefighters. Why they have it, I don't know. But nonetheless, we're going to keep on going. So the building code does allow, and actually I'm going to stand in front of the monitor so no one else can see. So what would logic tell you? If a fabric, let's say any product goes within the test chamber, passes the burn portion of the test, and fails the hose stream test, does it receive a rating? You see, does it receive any kind of rating at all? Does anyone think? Show of hands says, yeah, that product that fails the hose stream test is going to achieve a rating. Hands say yes. Yes. Bold. Bold. 2. Okay, fantastic. Well, you guys would be right. No, it does obtain a rating. It obtains that 20-minute rating that we've already been talking about a few seconds ago. So the building code does allow for an opening protective rating of 20 minutes, even for doors that don't pass the hose stream test. And that's, once again, it's for those applications that we were discussing in the beginning of the program. Different applications, you're going to only see 20-minute ratings that are needed in corridors and some of those types of separations that we're going to commonly see. So logic would say, heck no, why would you fail half of the test? Why would you look? And I guess in this world, you still obtain a rating, but a 20-minute rating under UL10B. So when we're going back to the scope under UL10D, this is the same slide that we saw. It's not to be provided for in non-structural separations exclusively. That's the only time this UL10D is going to be applicable. But also, it's not to be substituted for structurally hourly rated partitions or opening protectives that have been tested for fire endurance hose stream. What did I say that hose stream test was for? Did anyone pick up on that? Did I say it enough times? Wow, thank you guys. You're awake. Outstanding. All right, so structural, that's what we're talking about here. That UL10D for non-structural separation, UL10B with the hose stream for structural. So will this stuff pass? You guys saw this fabric product. Show of hands, is that fabric product that's going to pass that hose stream test? No problem at all. That flimsy fabric product burns 1800 degrees, hit with the cold water hose, it's going to pass. Doesn't burn this size hole through the door. Yes or no? Hands say it's going to pass. You guys are bold. So this is one of the first tests of this fabric product under UL10B. They didn't know this stuff, how it was going to perform. You can kind of see it's on fire in the bottom right-hand corner. The fixtures were on fire. This stuff emitted a great amount of heat in this. It's an 1800-degree test. And immediately I want you guys' first blush reaction. Cold water hose is going to go on. You're going to tell me whether or not this fabric product passes this hose stream test. Size of a quarter, as small as, or the thing blows out of the jams entirely. You guys are going to tell me Immediately. I don't want any hesitancies, no fluctuations. I want to know immediately. Bad videography, too. I apologize. Did it pass? Did not pass. Did not pass. Did not pass. So that's kind of a brutal summation of what we're talking about here. Is fabric product under UL 10B can never be placed in structural openings is what we're talking about because it fails that test every single time. And that's not this manufacturer, that's every manufacturer. We're very upfront about this. Fabric product is exclusively only used in 20-minute rated UL 10B assemblies based off of that hose string test because it's all about the life safety of occupants. That's what we're discussing. That's what we're concerned about. Fabric product, never to be placed in applications greater than 20 minutes under UL 10B because of that, what you just said. So where does the code say it may be used? So we're talking about these fire partitions and corridor walls specifically, 20-minute ratings and those. Once again, going back to the applications, I keep harping on it, but once again, it makes sense. It's intuitive, right? When we're trying to separate a firewall in between area separation, it makes sense. You're going to want 3-hour protection in between those two buildings. But when you're egressing out of the building in a corridor, it makes sense that you can have a 20-minute rating. You're going through there on the way out, so 20-minute rating makes sense. But also in smoke barrier walls that you're going to see 20-minute ratings as well. Those are you're going to commonly see. Where you're never going to be able to see this fabric product, ever, never, ever, never, ever, ever, never, ever, ever, ASTME 119 rated applications, and I'll tell you why. So we just talked about UL 10B, right? It's an opening protective fire test, right? This is that test, except it's for walls. ASTME 119 is a wall test, not for opening protectives. And in this test, so it's the same 1800-degree furnace. It's the same rigmarole that I've already been discussing, but it's a wall within that application. And the crucial tenet is the heat transfer. So for the duration of this test, whether that's 1 hour, 2 hours, or 3 hours, that wall cannot emit on the cool side of that opening over 250 degrees. So let's get hypothetical here. So the wall's going on, or fire, it's going on in the kitchen right here. This is an ASTME 119 rated wall. This side cannot emit heat greater than 250 degrees for the duration. That's 2 hours, right? This side cannot emit less than emit under 200 degrees for the duration of that test. Why? I sound like a 2-year-old. Why do you guys think that? Why would that be the case? What's that? Anyone? What?
Presumably somebody's occupied.
Conceivably, right? Thank you for being bold today, sir. Thank you. I appreciate it. Happy Tuesday. Wahoo wah, right? All right, anyway. So we're talking, it's ASTME, it's a wall test, right? What do you guys have on your walls at home? Anything? Anything? We've got national banner trophies on our walls. I'm just kidding. Anyway. ASTME 119 rated. Some people, I had a woman in D.C. a couple weeks ago. Sir, I have fine art hanging on my wall. I said, okay, ma'am, gotcha. No problem at all. The people have furniture, they've got paintings, they've got crap all over their walls, right? And that's the key. They used to test this with a cotton ball. They had to put a cotton ball against the wall that was being tested. They let that fire burn, and if that cotton ignites at about 260 degrees, that product would fail the test. So I guess we've gotten a little bit more advanced in this. So this fabric product, never going to pass ASTME 119. Rolling steel products, never going to pass ASTME 119. And it's just crucial. Whenever you have somebody come in, it's fabric product, carries a 1 hour ASTME 119 rating. It's crucial to ask for testing data and listing reports that indicate that. Because it's crucial. You think this fabric product that we just saw blow out of the jams entirely under a cold water hose, and this cool side is less than 1800 degrees? It's probably about $17.99 to be quite frank with you. So it's all about maintaining that heat transfer, right? Under 250 degrees for the duration of that test. Fabric products certainly don't obtain it. Steel products don't obtain it. And that's just crucial for you guys to understand. So let it be known. Alternative methods approval. This is where it gets boring, so pull the pillow out. Anyways, AC77 is a common route by which manufacturers or architects or AHJs, they go about trying to get these things passed. Because the reality is it's not in 2021. It's not any cause other than 2021. AC77 is a common way to kind of go about doing this. Essentially, it fills a gap in between the International Building Code and International Fire Code to create this purpose here. Right, so we're trying to obtain code compliance. That's the goal here. You're trying to obtain code compliance through an alternative means, essentially. That's what we're discussing. This could be a common document that you see. Scope, right, smoke containment systems we commonly see at elevators and elevator lobbies. And also, it's an alternative to just a 20-minute rated door application. So to kind of summarize the limitations that we're talking, smoke containment, the elevator or elevator lobby only. It's recognized as an alternative maximum to a max 20-minute rated fire door assembly. And lastly, it's not able to be placed within a required path of egress. Except one technology, and it's this one. There's only one egress technology that complies with IBC Chapter 10. That one, baby, as displayed by our best friend Vadim Littman. So anyway, this technology actually is code complying under 10.10.1.2, as we can kind of see. It designates itself as a side hinge swing pivoted door by code. So as you kind of see, there's this Velcro lining along the left side here, or on the right, the yellow's on the right side. As you kind of see that Velcro lining that seals the door, there's a push to exit. You push through that, the door goes open, but then there's this weighted bottom bar that slams the door shut. So there's like a closer affixed to the bottom bar there. So by code, it's a side hinge swing pivoted door with a closer and everything. It's just kind of an alternative means of doing that. It also passes the door opening force test, right? 15-30-15 rule. You've heard before, 15 pounds of force to release the latch, 30 pounds of force to put the door in full motion, and lastly, 15 pounds to keep the door fully open. So it passes those two, does not pass the third, though. This is a great slide. Anyways, so it is ADA compliant as well. Less than a half-inch threshold along the bottom there, or as you can kind of see the individual in a wheelchair navigating right through that in the required path of egress. But it does not pass within this particular application. In theory, right, all these doors at 80 inches above the surface floor are supposed to be 32 inches wide. That's by code. Reality is we just don't have a weighted bottom bar that's able to be sealed, right? This full opening curtain width, we can't get that bottom bar to seal it shut. But let me tell you, if anyone wants to come up with some ideas after I've got all afternoon, we come up with this, we could sell it back to manufacturer and be loaded and set off. Trust me. Anyways, let me know. So it passes 2 out of the 3. Unfortunately, that has never been too much of a problematic occurrence in trying to get it passed, especially from the side hinge swing pivot door motion specifically. So what are we talking about? So when can these fire protective curtains be applied as opening protectives? There are 4 instances that we commonly see. Obviously, 2 types of opening protectives, one without egress, one with egress that we've already established, and the last 2, smoke protective with egress, so just carry a UL 1784 rating, but also deployable draft curtain. No side guides, it's not a rated application, it's not a rated assembly. It's just about channeling smoke to a vent or triggering it against a fire alarm. So those are the exclusive applications that we're going to commonly see it. This is where it gets really boring, the case studies, I'm telling you guys, be careful. Anyways, R2 occupancies are where we're going to commonly see these. So R2s, I don't know how many R2s you folks do, but on residence halls and such. Passive requirements are half-hour rated corridors, 20-minute rated doors, and no 2-story openings by default. In this corridor vertical opening separation, they're able to create this 20-minute rated corridor with these 20-minute rated products, right? They carry the smoke rating, they carry the 20-minute rating under UL 10B, and then just down the way, they were able to create this opening, 2-story opening, but able to segment it off with the fire protective curtain assembly to make it code compliant. This is actually an I-1 occupancy where they needed 24-hour custodial care. So the same bylaws and restrictions on R2s are applicable on I-1. So people are going in and out there all the time. This is just, once again, a similar situation as fabric product closing off that corridor to create a 20-minute rating along that corridor. In I-2s, though, this is another comment. So R2s, I-1s, and I-2s, I don't know how much healthcare you folks do, but nonetheless, smoke-rated corridors, smoke-rated doors, and also new 2-story openings. So we're going to commonly see. And if you're looking at this bottom picture thinking, what the heck, you're thinking right. I guess they couldn't send the building into an alarm state, typical day-to-day action. So this is what our animations team came up with. Fantastic, right? Nonetheless. So that's it. Fabric product closes off that waiting area that was up here. They wanted the sunlight to be able to come through, wanted that to maintain open. So once again, it carries that 20-minute rating in the waiting area there. Here's another interest in trying to create that 20-minute rating along the corridor. And God forbid that drawer were open when this thing is full. Come on, what are you thinking? Don't you know that there's a curtain overhead? But like we were talking about, that bulkhead's really limited. It's small. That's what we're trying to put. Less than 10 inches that we commonly see for this fabric product we use. But once again, based off of the applications, it makes sense where it's only 20-minute rated separation. So that's what we see in this corridor as well in the I-2s. Elevator lobbies are going to be the most common instance that we're going to commonly see, either creating an elevator lobby or actually at the elevator hoistway protection itself. I might be preaching to the choir telling you guys this, but nonetheless, typically the elevator shafts are 1 hour rated, and then the car doors function as an open and protected by code. But oftentimes it's hard to get a smoke rating at the hoistways themselves. So these fabric products, they carry the UL 1784 smoke rating, and this is what you see. So there's smoke partition walls. They're being able to put the elevator face, so the opening protective, the elevator car doors. They couple with this fabric product in an intended path of egress to create a code-complying elevator hoistway or lobby protection. Yep.
So how far in front of the doors are that covered?
It's about 6 inches. It's about 6 inches tall there. So obviously you're going to want to know, that push to exit's crucial, right? You're going to get out of an elevator. Great, okay. But once again, you kind of have to see that illuminated green push to exit sign, as you can kind of tell. Doesn't make a lot of sense, right? That's kind of why we go for the elevator lobby. Yeah, right. In some instances, they see it. I mean, in this particular instance, I guess in this particular, they needed to have the turnkey. So you never can tell what kind of the buildings are. I don't think there's a requirement is the biggest thing of what the distance is. We commonly see right against the elevator, and sometimes they have it like this.
Is that one unit, like one width unit, or is that multiple?
That's one width unit. Yeah. That's just for egress out of just one curtain assembly. It's a good question. So that's kind of what we see within there. But then the elevator lobby route, typically when you see buildings, depending on your occupancy classification, the occupant on the floor plate, greater than 3 stories in schools and such, we were just dealing with one of these. You have to create elevator lobbies, which is the common route. 1 hour fire barrier construction. This elevator lobby, they were able to utilize just create that separation with the curtain itself, 20-minute rating, same kind of unit. But obviously you can see egress out of the building, which right as you get out of the elevator, it's trying to create that passive protection of the elevator lobby itself. I also would like to mention, you kind of see this flap here, this egress flap along there. That's not an egress flap. I shouldn't even say it. It's a pass-through slot. It's for this convex concave nature that's created in those UL tests. The fabric product, that whipping motion, that's the only way that fabric product is ever going to be able to pass. If you see somebody trying to get through this curtain, right, you have to have somewhere that air and the burn portion of the test to go through. Try to see somebody go through that. That's like a contortionist act that's needed. So it's not, if it's just that 24-inch pass-through slot, it's not an egress opportunity. You need a full height egress door that we were just talking about a few minutes ago. Then it's smoke and draft control. Some different instances when it was exclusively a UL 1784. This is an instance where it was sitting right off of the elevator face. So the fire service access elevator. Obviously, they have 2 curtain products complying for both of the openings there. As you can kind of tell, the side guys are right along the edge of the elevator. So this, you never can tell. But that's a good question. Once again, two deployable egress flaps with 1 assembly, like we were discussing. So this entire curtain assembly, that's what we're talking about here. But it has 2 egress flaps for that opening. It's at the Nike building. Sorry, what's the question? Yeah, sure. Okay. This fabric product. We got one that I'll actually go to in a second, and we'll get into talking. I'm glad you said that. Thank you. This is at the Nike building out in Los Angeles. They just, once again, just needed a smoke protective at the elevator hoistway itself. No problem at all. And then lastly, we'll talk about these extreme heights. This is greater than 15 feet in height. So we're with 1 barrel, we can go as maximum at 30 feet in width, but unlimited height. So this is well over 15 feet in height. We're still going to use this 1 barrel for this application. Still within an intended path of egress. I'd like to also mention, look, you're not going to want to have 250 people behind you trying to get out of this curtain. It's still Velcro, right? We know Velcro, when you get that old jacket, right, that keeps hitting stuff, that's the same kind of stuff, right? You're not going to have it in a high occupancy, a lot of people coming in behind you, but unlimited, 15, 25 people behind that's very doable and reasonable. Another elevator opening is about 12 feet in height, 12, 13 feet in height. Similar situation. And then care suites, so we talked about one instance where we go about an I2 occupancies. Care suites is another methodology that some architects go around making these code-compliant hospitals and such. And care suite separation is about separating the building into 22,500 square foot compartments. So this is kind of what they went with. So it's like they're trying to create tenable environments for the building occupants, right? You can't get somebody that's on an IV out of the building, but ordinarily you're trying to get people out of the building. This is kind of a defend-in-place kind of scenario that we commonly see. Passive requirements. Once again, what do they do with this filing cabinet? Are you kidding me? Out of your mind. Anyways, closes off that opening, creates that care suite, and yeah, so that's what we see there.
If it did hit the filing cabinet, would it retract back up?
3 times, and then hopefully, if it's not a filing cabinet, or if it's a person, it's going to get out of the way. If it's, greater than 30 pounds of force, it's just going to sit on top of there, unfortunately. That's just kind of one of those things. Once again, hopefully, if it's a person, they have a brain, they're, oh, okay, I get it out of the way this time. Yeah, that makes sense. Vertical opening separation. So this is the atrium that I was discussing that we get to. This is actually a non-ambulatory clinic down in the Carolinas. And ordinarily, you need 1 hour fire barrier construction at the openings to create 2 floors in common, at just one of the openings that we would commonly see. In this particular atrium, they were able to use these 20-minute rated fabric products at each of the openings and couple that with a reduced smoke evacuation system to create this code-compliant atrium. Design team and the AHJ said, look, I don't want to, if a fire were to break out within this atrium, there are all these corridors would be sucking wind into there, just channeling more and more fuel to that fire. To be able to close off each opening for no air transfer to come into that atrium, that's what they went with here. So it was a smoke evacuation system coupled with the 20-minute rated fabric product at 3 of the openings, not just 1. So that's crucial. Ordinarily, we would see some kind of rolling steel product, the 3-hour rated that would carry that 1 hour that would close off that one of those openings. In this particular instance, it made sense from the AHJ's perspective to just have the fabric product at all of the openings with the smoke evacuation system to close off the openings. Not in all applications, depending on the heights. In some instances, yeah, like if we're talking about trying to create an elevator lobby, certainly. If it's less than a 20-minute rating or you see a smoke protective, yeah, it is a lot more cost effective. But in some instances, it's not. Surprising. When you have like 16 egress flaps, it's not, you never can tell in those particular instances. A good question, but this is approved under alternate methods, obviously. I like to mention that as well. Not by default, by any means. Deployable draft curtains, we touched on these a few minutes ago. So this is the last of the 4 instances in the applications that we're going to see this fabric product being used. So once again, vertical spaces and escalator openings and exit access stairs. The only requirement is that it's made of non-combustible materials. Trying to trigger it against a smoke alarm and get it out of the building, that smoke out of the building. Ordinarily, if you're at Macy's, punks like me are hitting plexiglass like this. I still do it, unabashedly. But nonetheless, at escalator openings, this is just a way that you can kind of go about doing it, where it's obviously housed in the ceiling, drops on a fire alarm, smoke alarm, and power outage. So it's more aesthetically pleasing instead of having this goofy plexiglass hanging down from the ceiling and potential maintenance people getting mad at people like myself still hitting it at 23. Anyways, so that's what we kind of see there. You see that commonly at different instances as well. Exit access stair. Typically, we see this coupled with closely placed sprinkler heads, just trying to create that tenable environment. The smoke obviously rises, right, and that's the killer. And the fire is trying to create tenable environments and trigger it against the smoke alarm to suppress it, right? Active versus passive requirements. Alternate methods of approval. I was in a lunch and learn last week, and the guy was like, I helped design this. I was like, can you sign my code book? It was weird. Alternate methods of approval. The guy was in there. He was going into this long, drawn-out explanation. Thankfully, he didn't have to program for me. I got to the slide. I basically gave him the clicker. Nonetheless, they were able to approve this under alternate methods with massive curtains. So once again, they're not rated. They're not smoke rated. They're not fire rated at all. They don't have side guides. Just trying to channel that smoke, trigger it against a smoke alarm, and hopefully get it to a vent as well. Those are the only uses of this. And it was approved under alternate methods because of the extreme heights. He was going on and on and on and on, telling me about how, there's smoke that would be ventilated down into the subway. It's actually at Dulles. That'd be, going down in the subway and get on the metro rails and all this stuff. And this is all the calculations of the square footage. I was like, that's outstanding. Thank you so much for telling me that. Very, very useful. I'll tell it next time. So that's what we see there. And alternate methods approval, just another extreme height kind of condition. This is out in Vegas, just a cafe. Forget about the quiz. I'm not going to make you guys do it. I've never done it myself, so forget it. But nonetheless, I'd like to bring up one more thing that I think a lot of you forgot about. So if you guys want to see me at the front door, or if you could follow us on social media, one or the other, that would be great. Or I'll see you at the front. But yeah, other than that, I'm here for questions if anybody's interested. But thank you for your attendance. Appreciate it. Thank you. I'm going back right now.
Yeah, you want to go ahead.
Yeah, I don't think so.
Here we go. Stop. So, stop recording.